We're talking today about the different types of power in a facility, and primarily industrial and commercial facilities where there's a lot of motor load. There's basically two kinds of power. Your active power, which is the power that is really doing all the work, that's pushing the motors. Then there's the reactive power. The reactive power is referred to commonly as wasted current, because what that wasted current is doing basically is keeping the magnetic field around the motor satisfied. It's not really doing any work, but what it is doing is working to plug up your distribution system. There's two ways to store electricity. On the AC systems, we store it with capacitors, which is what this is here. In a DC system, they use batteries. So we're focusing on the AC side of the business here. And we have a little demonstration set up to show you how, with our products, we can eliminate that wasted current from your distribution system, improve your power factor in your facility, and save you money in the process. If you don't do this, then the power company greatly penalizes you for this, because you're passing all this wasted current back through your distribution system onto their lines. There's two ways of doing that power factor correction. One way is at the main switch gear, where you have to oversize your capacitors to allow for any fluctuation in maximum loads on your system. But there's really no benefit to the business owner to do that. The power company is one that really benefits by this, because what you're doing is you're trapping that current at the service entrance, preventing it from going back on the power company lines, but it's still stuck on your distribution system, wasting space and energy. So what we do is we take our capacitors and we size them for the motor loads, and we run them in parallel with the motor, which is a critical point, because by running in parallel, the motors aren't running through the capacitors, they're running in parallel with them. So if the capacitor were to fail, the motor would not notice any difference. It would be business as usual for the motor concern. But what we're doing by installing this capacitor in parallel with the motor at the motor, we're keeping this motor satisfied, because it's seeing all the reactive power as well as the active power that it needs to satisfy itself. What we're also doing is we're eliminating all that wasted current off your distribution system. So what we have here is this is a small motor, our capacitor, an amp probe, a simple kilowatt meter that's going to tell us what wattage this motor is drawing. Just a little simple quarter horsepower motor. And first of all, I'm going to just plug this motor in. Simple 110 motor. I'm going to put this little adapter in here so we can determine exactly what the amperage draw on that motor is. This is going to basically simulate what your distribution system looks like out in the field. So the motor's drawing 4.5 amps. It's the same on the neutral as it should be. So now what I'm going to do, I'm going to unplug this motor. We got about 120 watts. Now I'm going to basically hook this motor up in parallel with my capacitor to simulate what would happen in the field if we were to hook a capacitor up to a motor. Now granted, most motors would be considerably larger. We typically wouldn't treat a motor this small, because the payback would be too long. But with a larger motor that works harder, draws more power, runs more often, you can experience very considerable payback by introducing our products. So I'll just double check the amperage of the motor again. Motor's still seeing it's 4.6 amps, so the motor's happy, 4.7, everything's normal. Now, I'm going to plug in my capacitor. Basically, this is connecting, because of this splitter, it's taking it from the distribution system and hooking it in parallel with this motor. When this is plugged in, no visible changes to the motor's running fine. I'll double check and see what the current on the motor is. See if the motor is still happy. 4.6, 4.7 amps. Our little motor is happy as a clam. Now we're going to check the power on the distribution system. In theory, we should have eliminated all that wasted current off the distribution system from this point back. (2 amps). We've taken 60% of the wasted current off of the distribution system, trapped it at the motor load. So what this does is greatly reduces the strain on the distribution system. Probably 30% of the applications that we deal with are industrial facilities who think they need a new service entrance because their distribution system is maxed out. This is pretty good proof that we can eliminate that problem just by installing the capacitors. We see what our little kilowatt meter is down 10 kW, or 10 watts. So that's about a 9% drop in kilowatt consumption as well. So not only are we eliminating all the wasted current from your distribution system, we're also saving you money in the meter as well.